Hi, this is Professor Dave Olwell, and I'm talking to you today about Lab 4 from SE3302 Spring Quarter 2013. You should be able to see on your left-hand side of the screen the lab sheet for the lab, as well on the right-hand side of the screen a browser and an Extend Sim window, which I've already opened. I got the Extend Sim window by going to voyager.ern.mps.edu as we did in lab number 1. And this time when I went to the Systems Engineering folder, I selected Extend Sim instead of Minitab. And so that's open. So we will begin with the lab. You might recall that the purpose of this is to track the availability of a certain repairable system over a time and to see how it either settles down or settles up into its asymptotic availability. Asymptotic availability being determined by the formulas that are given in Blanchard and Fabricki. But the point is that they're asymptotes, and that's what we're going to explore in this lab. So to begin, we're going to do a discrete event simulation. So that means that we are going to need an executive, which goes in the upper left-hand corner of the model. We're going to need to create some items. There are 500 items. We're going to need an activity that is their lifetime. We're going to need an activity that is their repair time. We will need a queue for items entering each of these activities. That's one of the idiosyncrasies of Extend Sim. And then we'll need a way to move things around. So particularly from the queue to the activity, we can just connect it. From the activity queue, we connect it and connect here. But the issue is we're going to have things coming from the create block as well as repaired things going back into this queue. So to manage that, we will use, since there's no longer join blocks in this version, we will use a catch block and 2 throw blocks, which will move these items around. Throw block here and a throw block here. Okay, I don't need the library. Actually, I need one more item from a library, which is I need my discrete event plotter, which is going to be what tracks the output for us, and we'll get that in a minute. So I'm done with that window, and let's maximize this so we can see what we're doing. All right, to the create block. First, we're going to be creating items on a schedule, and we're going to create 500 of them at time 0, and that's the only time they're going to be created. I'm a person who likes to label my blocks, so I'm just going to label this the create block, and you can see, of course, that the label appears there. From here, these items are going to go to the throw block, and they'll be thrown to this catch block, which I'm just going to name catch. And when I open the throw block, it says where are these going to, specify catch item, and they're going here to the catch block I just defined. We'll call this throw 1. Okay, and they come to this catch block. From the catch block, they go to the queue. From the queue, they go to the activity block. And here's where I'm going to represent my item life. So I'll call this life. And items are going to have a certain life, time between failures, which we said in this case is going to be a distribution that's going to follow the normal distribution with a mean of 30 and a standard deviation of 3. Okay, and we're going to allow 1,000 items of these to be processed simultaneously, even though we only have 500. I should say at this point, I recognize I'm probably going a little quick here, but what you can do is pause this video, of course, copy what I'm doing in Extend, and start it up as we go through steps. So I'm going quickly so the video length won't be too long. Okay, coming over to my activity block, this is my repair. And again, we said that we would have 1,000 items in this. And here our delay is going to be specified by a triangular distribution coming from the problem. Minimum life of 2, maximum life of 4, and a most likely time of 3. And that's completely arbitrary, but just to illustrate how we're going to do this. Okay, the items come from here to the throw block. And from the throw block, they are thrown to our catch block again. Okay, so the flow is going to come into here, go through here, and when they come out of here, they're going to loop back. And just keep doing that for as long as the model runs. I'm interested in tracking my life, so I go to my life block, pull down menu, and L is the length of the queue, or how many people are in the activity. That's what I'm going to keep track of over time. So I drag that to my discrete event plotter. That's all that's necessary in Extend to set up my simulation structure. To run the actual simulation, I'm going to go to my simulation setup menu, and here I'm going to do it for 900 units of time, which is chosen to be 30 lives. I'll do one run, okay, and click OK. So now we're ready to take a look at this. To debug it initially, I'm going to turn the animation on, so I can see what happens. And I'm going to start the run button just to make sure I haven't messed any of my logic up. Now here's my discrete event plotter. I'm loading my 500 items. That's encouraging. Let's go a little faster here. And those will load. And I'm going to turn animation off now, just because time is short. And I can watch the discrete event plotter. To do that, I'm going to show the plot during simulation. I'm going to have it auto scale during the simulation, and we should be able to see what we obtained here. Let's try this again. So here we're seeing our data go through their cycle for these 30 lifetimes, and we can see the behavior that was placed in the first graph that was displayed in the lab sheet. And so in fact we do get something that looks very similar to that. So from this we could calculate what the asymptotic availability is, and to do that we need some scales on the right hand side. Sorry. Put those over here. That goes between 0 and 1. I did that with the trace window. Hopefully you've seen that before. Close that. And it is coming right at the 90% that we estimated, but it takes a while to get there. Okay, so to do the rest of the lab, all that's necessary to do is to go into the activity block and change the various distributions to Weibull. For example, my scale parameter was 15 and my shape parameter was 0.5. Okay, and I could run it for that, or I could change it to be the other values that are listed. Okay, now what you're required to do at the end of this is to do these 4 different distributions, and some of them are going to settle down, some of them settle up, and some of them are going to oscillate like we saw with the normal. The point is that they don't start at that asymptotic value immediately, and that's the point of the lab. So the deliverable for this is a 5-minute briefing using the graphs that you can extract. For example, if you can come here to this graph, go edit, copy plot to get just the graph copied. But you want to put a 5-minute discussion about what's going on for a program manager to caution that you don't start at asymptotic availability. It's an asymptote, and it can take a while to get there. That briefing we're looking for by the 2nd of May, which is Wednesday of the week after the lab. And then a lab period for week 5 is going to be students presenting this. So hopefully this was helpful. Again, I'm Professor Dave Olwell, the Naval Postgraduate School, and we will see you in lab.